PhD degree from the University of Newcastle upon Tyne, United Kingdom. His research in service-oriented architecture, component-based design, and software engineering tools and techniques has produced so far more than 40 papers, and 5 technical books titled Large-Scale Component-Based Development, Principles of Case Tool Integration, Component-Based Software Engineering, Integrated Project Software Environments, and Software Engineering Environments. Dr. Brown is currently an IBM Distinguished Engineer at IBM Rational Software, contributing to the technical strategy of Rational's design and construction tools portfolio. Dr. Brown, I'm pleased to welcome you to Uyms.
Thank you very much. So thank you for that introduction. I hope you'll excuse my English. It's much better than my Turkish. So I will try and speak as slowly as I can. I tend to get a little excited when I talk about the technology, so if I start to speed up and talk too fast, then just let me know, please. Just so you know who I am. As was introduced, I work for IBM Rational in the United States, and my responsibility is for developing large-scale software development systems for enterprise software in a number of domains, in financial services for banks and insurance companies, but also in federal systems and in defense markets, where they have very particular problems for how to build and deploy large-scale systems. I'm also a professor at the local university where I live, which is North Carolina State University, where we're also trying to do research into software engineering to try and extend the state-of-the-art in software engineering. So I'll talk a little bit about the current practice and also a little bit about the research work that's going on, both in commercial and in the academic world. So what I'd like to do is talk about why developing large-scale systems is difficult. And then I'd also like to talk about how we can be more effective in building large-scale systems today. And a lot of what I'd like to do is talk about what I see when I go and visit companies around the world, particularly in North America and in Europe, but also in Asia and other areas. And to look at some of the problems that they face, how those systems are being developed, and some of the most relevant techniques today for being successful building large-scale systems. So the first thing I'll do is talk a little bit about the challenges that organizations face. You all know these very well, so I'll do this very quickly. And then I'd like to talk about 3 particular concepts that I think are quite important today. One of them is about service-oriented architectures. It's very difficult to pick up a magazine or go to a conference without hearing about service-oriented architectures. So I'll talk a little bit about what that means. Then enterprise architecture, how you understand and build large-scale systems. And finally around business process modeling, how you get a closer connection between the IT systems and the business community. And I'd like to spend most of my time talking about the lessons and next steps. What are organizations learning as they try and apply these techniques? And how can you be successful when you apply these techniques in your organizations? So let me start with something perhaps fairly obvious. We know how to build large-scale systems. We also know why it's difficult to build large-scale systems. It's difficult because of several key factors. If we look at a lot of the research and the empirical data from the last 20 years of software engineering, there are lots of different ideas, lots of different models from Kokomo and the work of Capers-Jones and many other people in the literature. If you look at that work and you say, so what are they saying about building large-scale systems? It boils down to roughly the same sorts of ideas. That the time or the cost to build large-scale systems is based on several factors. The complexity of the system that you're building, how complex is it, how large is it, how many modules is it, how complicated is the domain that you're working in. And we can have some impact on the complexity by looking at the process that you follow. Is it a well-defined process? Is it a repeatable process? Is it well documented? So we can heighten or dampen the effect of the complexity depending on the process that we use. Of course, another big impact, perhaps the most important impact in practice, is the team that's doing the development. If you go to most large-scale development organizations, most enterprise IT organizations, and you talk to project managers, and you say, okay, you're about to start a new project tomorrow, and you can choose one of three things to control: the size of the project, the people you have on the project, or the tools that you use. You can choose one of those things to have control over. Which would you like to control? They almost all say the people. If I can choose the people, I can do this project. If I pick the best 5 people in my company, this will be easy. But that's not practical. You can't always choose the best 5 people for the job. In most organizations that I'm involved in, there are hundreds of developers. And if you have the normal distribution curve, half of your people are below average. Right? That's the way it works. So you can't handpick the team. So the complexity in the process have an effect on the team. And of course you can help with automation. You can help to capture data, to ensure you don't do silly things, make small problems. You can overcome some of these things with automation. But it's just one aspect of the whole problem. And if you look at Kokomo and all of these models, and you look at the numbers that are in those models, roughly it's this kind of formula, more or less. So we know why it's hard. So why don't we fix this? It's not so difficult. So you go to most organizations and you say, what's the problem? Manage complexity, have a consistent, rigorous, repeatable process, train your people appropriately, buy tools from IBM Rational. It's easy. But when you talk to people and you ask them, why is this difficult? You get a number of answers. The first answer you get is, okay, so this is my system. This is my bank. This is my software that goes into the nose cone of a missile, or runs a train system, or is responsible for social security in the government. These are my systems. So tell me again, which one of these is a good service? Tell me how I re-engineer this and use Ajax technology as my front-end processor. Tell me how Web 2.0 helps me. Tell me how Rational's tools will help me understand and manage this. So you pick one of these and you say, so what would happen if I changed this? Will my systems work? Won't they work? What happens if I want to re-engineer on a new technology base? Which of these will I rewrite? What skills do I need in my organization? Of course, it becomes much more complicated. So the reality is we try and solve these problems in the context of the situation we find ourselves in. Complex business processes that are changing frequently. You go to any domain such as financial services and you find they're competing in new markets. They're trying to provide different kinds of channels of access through internet, through handheld devices, by working with other delivery channels, supermarkets, internet access providers. They're trying to provide new services in new ways they never anticipated. These systems may have been built 20 years ago. They weren't developed for the internet, for handheld devices, for helping somebody who is buying items off the internet and trying to use some sort of paying mechanism like PayPal or one of these new channels for payment. How the systems work like that way. They weren't designed that way. And of course, a lot of partner interactions. What this means is, rather than developing new systems, a lot of what we do today is assembly of existing systems. So, a few weeks ago in the United States, I was talking to the developer, the chief architect of a large defense system. And I asked him to describe the architecture of this new system he was building. And being kind of young and naive, or not so young, maybe not so naive, I expected him to start to draw UML diagrams and draw use cases and start to do architectural diagrams on the whiteboard to describe this architecture. Instead, what he did was he went into this discussion with me for about 10 minutes about how he's working with one partner to develop one system, working with another partner who's built some software that they need to rewrite the interface. He's writing a bridge in between the two. He's working with some investor that's going to fund some new technology company that's a spin-off from a university because they want to put some new technology in here so they can get a grant from the government. I said, no, I want to know the architecture of the system you're building. And he said, this is the architecture of the system. That's what I do. I negotiate between these partners to put this complicated situation in place and try and somehow manage this as it evolves. That's the architecture of modern systems. This is not the way most people were trained 20 years ago when they were doing computer science, software engineering, data processing, systems architecture. This is a new world. So this makes things very difficult. As we add to that some of the complexity of the context within which we're trying to build systems today, we start to get some domain-specific issues that we have to address. So here's an example of some of the challenges that people face in the systems market, building software that goes in automobiles, or software that goes in defense systems, or telecom switching systems. The kinds of systems that they build have many problems. For example, there's a lot of compliance issues that are becoming more and more important. So I'm responsible for some development teams in the United States building software that we deliver to customers like you. I've never been in a situation where I get audited more, have to deal with lawyers, have to sign things, certificates of originality. Where does all this code come from? Justify every line, make sure you didn't use open source software in inappropriate ways so that we have licensing liabilities. Making sure that the people that work for me are certified software engineers, that we're using ISO 9000 standards, that we're using COBIT, that we're CMMI certified. All of those issues become more and more complicated for developing and delivering software. Of course, the teams are more distributed. Again, IBM is a large software development organization as well as a provider of software. IBM has 44,000 developers all around the world. Trying to manage that is very difficult. There's no project that I can think of that's done in one location. There's a kind of joke that's at IBM about what do the letters IBM stand for. Some of them are a little too rude to repeat, but some people say that IBM stands for I'm by myself. Everybody's in their house, they're at Starbucks, they're working on their machine independently, connected over this large network of systems. So I myself don't have an office anymore. I got an email one day that said, you're not coming into the office enough. We've reassigned it to somebody. So I have to work from my home. I said, I'm sorry, I won't work with customers anymore. I'll come into the office instead. They said, no. So people are working all around the world in distributed systems. How does that affect development? It has a huge impact on development. So add to that the global nature of building systems. So, for example, many of you know IBM, and it's a large organization. Where is the largest research department of IBM? Is it Watson? Well-known research department? Is it San Jose? Bangalore and China. Bangalore and China, that's where our biggest research is. We outsource a lot of that. We develop in other countries. We go where labor rates are cheaper. We go where the talent pool is, where the people are being trained. That's what every organization does. Every financial service organization does most of its development in places around the world. Not just for cheaper labor rates. Perhaps that's the way it started. But for other reasons too. As I say, that's where the talent is. If you go to North America and Europe, and you look at recruitment for computer science at universities, the trend is terrible. In the last 5 years in the United Kingdom, recruitment for students coming onto computer science courses has dropped by 50%. 50%. So we're not able to recruit and train enough new engineers in software engineering, computer science, to fill the vacancies that we have. If you look at other countries, emerging countries, of course, it's growing rapidly. So the talent pool is changing, and we have to take advantage of that. Also, of course, organizations are trying to reduce risk. So they're trying to develop in multiple regions around the world to reduce risk and to provide local control over the development resources. Control that's focused on the region that's developing the systems. So it is valuable to have development organizations in places where you sell. That has a huge impact. So global sourcing and outsourcing is a real factor around the world. All organizations of any consequence use that today. And it's changing in nature. So we have to add that to the complexity of why it's hard to build software systems. The problem is, if you talk to almost any organization developing around the world and you say, so how's it going? Is it successful? Are you getting the benefits you expected? Effectively, labor rates for developing software for writing code. In the United States, they say labor rates for writing code is free. Writing code is free. The amount we have to pay for it is negligible compared to everything else. So why is software more expensive? Because that's not the dominant cost in building software. Writing code perhaps never has been, certainly isn't today, a key factor in the cost of code. It's building the right code. It's deploying it effectively. It's change management. It's ensuring it can be distributed across multiple platforms. These are the issues that we face. In IBM, we have maybe a 6-month release cycle for new products. We do maybe 6 weeks coding. So what's the rest then? The rest is interacting with our customers to make sure we're solving the problems they need. It's dealing with all the lawyers and the auditors. It's going through the test cycles. It's the beta program that we do to get feedback. It's the hardening of the code. It's the translation of the code into different languages. We have to release simultaneously in 12 languages. There's a whole set of things that we do that make developing that software complicated. It's not about writing code necessarily. So the economics is changing. And the economics of offshore development is not about necessarily labor rates. And a lot of the issues that we face are not that we want to say, here's a piece of software, and it runs on this box here. Make it run on this box here. Go away and come back when it's finished. That's pretty easy to do. We know how to do that. We know how to get offshore organizations to do that. And why is it simple? Because the requirements are very fixed. That's not the way we're using resources around the world. So when we have to innovate, collaborate around the world, that's when the cost structure begins to change. I am involved in a large project with a multinational bank. And one of the first regions that they're working with is with Turkey. And they're involved in a large proof of production project that recently has gone live in one of the banks. And about 2 months ago, we were reaching that critical point where we should have delivered the software and we had this big meeting with the folks in Turkey. It was a big meeting with people in the US, Europe, and Turkey, trying to work out where we were, why there were some challenges. We had 2 hours on the phone discussing this. And in the United States, there were about 7 or 8 of us in a room. And we put the phone down and looked at each other and said, what are we going to do here? And there was only one answer. The next day, we all flew to Turkey because we couldn't work out what was going on. Collaboration, the discussion about this was so difficult. The only thing to do was to fly over and talk. And that's what most large-scale systems are like. It's difficult, it's complicated, and the communication is a real problem, even though we've got lots of help with computer systems, telephones, all of those things. So how do we overcome some of this? There are 3 things that most organizations are investing in that they think will help. There are some successes here and some challenges. The first is service-oriented architecture. And what they mean by this is a couple of different things. The first thing they mean is we have to think about the systems that we deliver in terms of the services that are required by our end users. So when you talk to managers and executives and consultants in companies and ask them about service-oriented architecture, what they talk to you about is, how can I be more responsive to my customers? What services do they need from me? How do we currently deliver those? Which ones are important to my organization? So for example, one example is, right now we're trying to help IBM's own CIO, the information office inside IBM, that provides all of the systems that run IBM. Our accounting, our HR systems, our ordering systems, all the software that runs IBM. You can imagine it's large and complicated. And the problem right now is, of course, we're trying to reduce cost of how we run IBM's own systems. So, in order to solve that problem, what we've got to do is to say, what are the key services that we provide to consumers? Which ones do we need to implement ourselves? Where can we buy packages? Where can we outsource? So, of course, the way that we do our human resources function or our pension function, IBM doesn't do that. They contract with somebody else to do that, because that's not something that we need to do ourselves to differentiate. How we deliver products to market is something we want to do ourselves. So we've had to relook at our business processes and think about the services that we deliver and redesign our IT systems to match them. And that's where we'll be in savings. Every organization is doing something similar. They're thinking about how they deliver services more effectively. The second part of service-oriented architecture is to say, so how do we actually deliver those services in practice? Given that mess of a picture that I drew of all of those systems, given I want to re-architect and rebuild my systems to be more effective, how do I do that? So there's a technology issue around service-oriented architecture. How do I begin to look at that complicated set of systems and extract the key services that are delivered by the IT systems so that I can more effectively put those together? So of course there's a new programming model and a new view of the infrastructure that delivers systems. Architectural styles such as service buses, enterprise service buses, ESB, styles such as connection architectures between multiple channels that are accessing shared data sources. We've done that many, many times with lots of customers. We know good ways to allow multiple channel access from handheld devices, internet access, kiosks, people walking into the branch of a bank. They all want to do the same sort of thing. Check their accounts, pay bills online, transfer money. So how do we do that consistently with these multiple channels? Those are the sorts of things that we're looking at trying to do with a consistent architectural approach, delivering a consistent set of services regardless of the channel that's accessing the information. This is one example of a style of service-oriented architecture. And of course, the technology behind that to make that work involves things like web services, web service definition language, WSDL, those sorts of languages, XML streams as ways of servicing data. So there's a technology aspect. The second part of how they're trying to solve this problem is enterprise architectures. What that means is the kind of person I described who is the chief architect, who is doing this complicated negotiation between his partners. He needs to have a view of what's going on in his organization. What projects do I have in place? Who's working on which pieces? What infrastructure do I have in place? What plans do I have for the architecture of future systems? What business processes am I trying to support? He needs a complete view of these, at this level, of the kinds of systems being developed. This is what people call their enterprise architecture. They need that view of the systems because they have to make some key decisions and choices about how to allocate resources, about the kind of technologies to use, about the kinds of skills they need in their organization. So there's a lot of interest surfacing around enterprise architecture and its relationship to some of these problems I've explained. Global development, service-oriented architecture, some of these issues. The third part of how people are solving this problem is to do with business process optimization or business process modeling. What this means is An example is, what we would like is, if I'm a business person and I'm responsible for thinking about, let's say I'm in a bank, and I'd like to think about the problems that people have when they want to open a new account. They come to us, they give a lot of data about themselves, about their income, about their address, about their credit history. And we decide if they're going to open an account and what kind of account is appropriate. Suppose we want to make that a better system and have more people able to come to the system online and open an account more easily with us. Then I would do some modeling of that business process. How do they do that today? When they come online, what data do they have to give? How do we do a credit check? What kind of credit limits do we have? What kind of offers do we have on new accounts? We go through all of this and we design the business process. And then we try and work out how our IT systems will support that. So we have a business model of the system. Wouldn't it be nice if our business analyst could virtually click a button and say, generate some language from this business description that can run on my runtime? A business process execution language, for example. Wouldn't it be nice if my runtime understood this execution language and could connect existing systems in relationship to this business language? And then I could orchestrate how my systems work together to provide this business solution. That's the fundamental basis of a lot of the business process modeling, business process optimization work that's taking place. Of course, it's nowhere near that simple. We wish it was. But of course, once you start to look at the business process and you start to generate some language that's going to be executable, you ask some interesting questions about performance, availability, scalability, integration with existing systems that may be 20-year-old COBOL applications running on an mainframe. How does that work when I generate this business process execution language? Well, of course, that's hard stuff. That's what architects do. They try and plan and architect and implement these kinds of characteristics into the systems they build. So we still have to solve that architectural problem. But we now look at it in the context of solving this business process issue, this business process modeling approach. So those three areas, service-oriented architecture, enterprise architecture, and business process modeling are really the cornerstone of how organizations today are investing and building new solutions. So what are we learning from the organizations that are doing this? Well, we're learning that their view of service-oriented architecture is changing. As I mentioned, there are these three levels of thinking about services: as a business issue, as a technology issue, and as an architectural issue. And some of the most successful organizations are beginning to recognize that those three views of services are fundamental to making any progress in service-oriented design. We're also learning that there's a set of ways of viewing the architecture of the systems you're building when you think from a services perspective. What I mean is that the traditional way of thinking about client-server systems or end-tier systems is sort of characterized in a set of layers for how people would like to build systems. From the view of the end users interacting with the systems at the top of this picture, the consumers, through a set of business processes that are a set of connections of how systems solve the needs of the consumer, supported by a set of technology services that essentially link into the back-end systems, their customer database, their existing operational systems that perhaps do claims processing in an insurance organization, or do online account management. So they call into these back-end systems and they treat them as components accessed through well-defined interfaces. So we're beginning to see organizations focus on this as their blueprint for how they're going to develop systems. But they need to solve some very hard problems when they begin to look at it this way. This doesn't remove the need for good architecture, for you to ask questions and answer questions about the architecture of the systems. issues to do with security. If I'm accessing something from the internet, or from a handheld device, or it's a trusted bank clerk in a branch in the street, how do they access this information? What kind of level of security is needed? And how do we manage that security? How do we test the system for that security? How do we document? When we make changes for the system, what regression tests are needed? We have a lot of issues that need to be addressed, particularly when the developer of the system perhaps isn't aware of which channels will access that information. So how do they test it effectively if they never knew it was going to be accessed by a handheld device? And what some of the issues are of using handheld devices over an insecure wireless network. They never expected their service to be used that way. So why would they have tested it? So we have to start to introduce some concepts about how do you build systems for secure access, for example. And many other issues too that have to be addressed, many of which we don't have time to go through. But we begin to look at this and say, as architects, there are some new techniques we need to learn if we're going to build systems in this service-oriented world. And of course, we're spending a lot of time in IBM, in universities, and elsewhere, gathering these best practices and beginning to document these best practices in books and papers, but also to automate those in tools. We also have to then think about the process that people use, the method that they use to build systems. How is that changing as a result of these kinds of systems? Well, if you sort of simplify a great deal what most organizations are doing when they build these kinds of solutions, they're essentially doing three different things. They're doing process modeling on the left-hand side, where they're beginning to say, okay, I have a new problem, which is account management in my bank. So I need to first of all understand what the goal is. The goal is we need to reduce the time it takes for somebody through an internet channel to open a new account. We want to make sure that we increase the number of accounts that are opened in our bank by 30% in the next 12 months. We want to make sure that we get more people from certain demographics, maybe people under the age of 20, to start to open bank accounts. Because once they open a bank account with us, it's so difficult to change accounts that we have them for their life, for their career. So we want to increase that number so that we get better penetration into maybe universities, so that more people in universities open accounts with us. So that, for example, could be what their goal, their mission and their objectives. So how would we optimize our account opening to solve those needs? We would go through some process modeling. What would appeal to people of a young age to be able to open accounts? Well, they want to do things online. They want to do things by sending SMS messages. They want to be able to access information easily and quickly about their bank account that's up to date. Maybe that's one of the key criteria. How would we change our systems to provide that service, to make our accounts more attractive to the kind of demographics that we're interested in? These are the problems that process modelers face, that business analysts face, when they're trying to design new systems. So they go and they do some process analysis, they design some new processes and so on to meet those needs. Once they do that, and they describe some of the changes they want to make, we then have to do some service modeling to say, how would our existing systems need to change to provide the right capabilities? So we analyze our existing systems. How would we do that today? Do we understand these 20-year-old COBOL systems that were developed by people that don't work already? Do we have the source code for these systems? It's amazing how many companies don't have source for some of the systems that are running their mainline businesses. So the answer may be we don't touch those systems. They run, we don't touch them. I was visiting the FAA, the Federal Aviation Administration in the US, about 6 months ago, and they were showing me around, and I was leaning on some box, and they said, "Don't lean on that. That's managing all the traffic in Chicago." So I kind of went, okay. So we have to look at our existing systems. We have to say, can we reuse these in some way, or do we have to develop new software? So we do some service analysis, And maybe we have to specify some new services and build some new implementations in new languages. But maybe they have to integrate with our existing systems on host-based system or back-end systems written in languages that we've long ago forgotten. So we have to do maybe some generation of the interfaces to the existing systems. Or maybe we have to re-implement some new pieces of the system. So we have a description of the process. We've gone and we've seen if we can go and harvest from existing systems, and maybe we have to build some new pieces. And of course, finally, we have to bring all of this together. So the orchestration has to pull all of these pieces together to execute this system. So essentially, it's a kind of workflow, orchestration environment that pulls all of these services together. And for this orchestrated service, maybe we put a number of key process indicators, KPIs, some measurement information, so that we can then feed this back to the business. So over the last 24 hours, how many accounts have been opened? What was the average response time from somebody starting the process of opening an account to us finally saying your account is open? How many people under the age of 20 have opened accounts in the last 24 hours? We'd like those numbers, because otherwise how do we know we've met the need that we have? So we'd like to be able to describe those in the process to say, the way we answer those questions is we look at this information, or we look at this flow in a process. And we can automate that in the process execution language. So that's where these KPIs, these key performance indicators, fit in. And we can have dashboards to show us that. So this is the way most organizations are looking at the delivery of systems today. Process modeling, service modeling, and then the overall implementation. As we do that, as we build those systems against this blueprint, there are different ways to address this problem. It would be nice if we could start top-down and build everything from scratch and do the analysis of the kinds of processes that we wanted and so on. Most organizations don't have that luxury. Many organizations start from the other end. They say, we're spending an awful lot of money on our existing systems. How do we reduce that? So they look for opportunities to extract services, to rewrite some capabilities, to outsource capabilities. So they're doing it by doing mining of existing systems. Other organizations are actually starting from the outside in. They say, if we could do one thing this year that was new, what would be the most important thing for our customers? And they try and do some analysis of that, and then they look at solving that one problem, and then they work on the next problem, and so on. So we have lots of different opportunities here to produce systems that comply to this kind of blueprint. But of course it affects the whole life cycle. Let me just take one simple example. As I'm building service-based systems in this way, we have to ask ourselves one of the key questions. How do we test those systems? How do we know if it works? We're assembling a set of pieces, many of which we don't have control over, in technologies we don't know, running on platforms we haven't spent much time on, or consumers coming through channels we didn't expect. So could you write me a test script for that, please? Test one. So we have to think about testing in a little different way than we did before. So there's a lot of energy going in right now to describing how you would test such a system, how you do runtime analysis, how you would look at, for example, some sort of scan of how these systems interact at runtime, how these services interact, and looking at the interaction patterns for certain characteristics. So, for example, one of the tools that we're working with IBM Research on right now will run a system for a certain length of time, let's say 20 minutes, and produce a service scan that produces this map of all of the service interactions that occur during those 20 minutes. And then it will do some automatic discovery of patterns of interaction. So this pattern between service A and service B, where it made a call, did a callback, then called C, then called D, back to C, back to A. We see that pattern 374 times in that 20 minutes. So what is that? Oh, that's what happens when we do a credit check and the person has a credit score under a certain limit. That's what that interaction is. Ah, okay. So let's take those out. Okay, we see this other interaction between B and C where it goes backwards and forwards 4 times in a short period of time. What is that? Oh, that's where the user entered an invalid information. We did some validation of the field. They re-entered the information, then eventually they go, okay, so we understand that, take that out of the picture. And you go through this, and then you're left with some interactions, and you say, so what's this? Oh, well, this is what happens when we get a queue overflow because we had a certain number of applications that was past the buffer that we expected. Ah, so this is an exceptional problem that we haven't catered for, that our system didn't understand. So we begin to do that kind of analysis, that runtime analysis of testing of service interactions. It's a different way of thinking about testing. And we're providing tools and technologies to support that kind of interaction. There's a lot of interesting research challenges there that we're beginning to look at for how we do this more effectively. We've got a number of examples. I don't have time to go through all of this, unfortunately. But we've got a number of examples here in many domains. The obvious domains I've mentioned are financial services, retail organizations, telecommunications. But we're also seeing interesting applications of some of this service-based design in areas you perhaps wouldn't expect. Perhaps in the defense world, real-time embedded systems, networks of systems, systems where there are some very interesting hard real-time problems, very tight performance deadlines. So then you can ask some questions like, well, does this inherent late binding that you get from service-oriented solutions? Here's a service, it's making a call to a set of operations on an interface that at runtime will decide which piece of software will actually get executed to solve that problem. That kind of late binding pattern for how you build systems obviously has some challenges when you have hard real-time deadlines. So how do we architect systems with that kind of problem in mind? We're starting to see some interesting examples. Here is an example from the United Kingdom's Ministry of Defense system where we built such an application. We tried to orchestrate some of the interaction between some of their existing systems. We used an enterprise service bus architecture as a way of connecting those systems. And we applied a governance mechanism on top so that we made sure that we met those needs. A high-level architecture of the system, which I won't go through here. But I'd be happy to talk to you about this example or other examples in other domains if you have interest. There's a lot of material around on IBM's websites. I can send you more if you're interested. So let's talk a little bit for the last few minutes. Up till 1:45. Is that right? Okay. Don't want to keep you from lunch. One of the lessons I had from talking is never keep people from lunch. Never be late to lunch. So let's talk for the last few minutes, the last 15, 20 minutes, the last 10 minutes, about some of the lessons we've learned. So one of the key lessons we've learned is there are certain situations, certain kinds of domains and architectural situations that are more appropriate for a service-oriented approach than others. And we can look for those when we talk with organizations and focus our solutions on those. So there are a number of those, some of them are listed here, but let's talk about 2 of those that are the most obvious. Multi-channel access to core services and building an IT infrastructure for SOA. Multi-channel access. We see lots of organizations that are trying to provide this multi-channel access to some single set of information. So let's, for example, the obvious one is customer information that's provided as account information and so on. A lot of different ways of getting to that information. We'd like to do this so that we don't have one set of software when somebody comes to on their internet channel, another set of software that's used in the branch, another set of software that's used from one geography to another. We don't want to implement the same, effectively the same business function 20 times. We'd like to do it once, regardless of how the channel is accessible. Well, we have examples of that. IBM has 160,000 people in its global services organization. At least some of them are building software, and we wish more were. At least some of those people are building software and doing things like this. We can capture that information. We can capture that guidance. We can embed some of that knowledge into our tools. So for example, in some of our tools, in some of the rational modeling tools, you can begin to describe some of these solutions and say, I'm building a solution which has got multi-channel access to a core service. What would make a good underlying system architecture for this? Don't make me design it every time. Don't even make me go to the books, you know, the Gang of Four patterns or some of the other books that tell you what are good patterns to do this. Put them in the tool for me. That's what automation is about, right? So do this for me and be able to generate code that complies to this style. And then tell me when somebody changes the code if it deviates from that style. Again, don't force me to go do manual checking to see if they've broken the style guide. Automate that for me. So our tooling, and tooling in the marketplace in general, is beginning to be able to do that, to apply these patterns, to look for those patterns, and to enforce those patterns. Similarly for other sorts of patterns, one of the key ones, of course, is building a service bus that connects multiple heterogeneous systems through one channel. And we're seeing a lot of interest in how do we create that channel? What kind of capabilities does it need? How do we provide that in a consistent way? Whether we're working across a Microsoft.NET platform, a Java-based distributed systems platform, maybe a mainframe-based Z-series platform. Yet we have a single set of capabilities that perhaps when we access our customer database, maybe we've, over the last 20 years as a bank, maybe we've merged with 3 other banks in the last 20 years. And they each have their own customer databases on different platforms with different database technologies. But when somebody asks for their address or their account information, we need to go access all of these and aggregate the information. How do we do that? How do we provide a single channel of services across those? Again, we have examples of how to do that. What capabilities are required inside that layer. So let me give you an example of an anti-pattern, how not to do this. One way that people started to do service-oriented architecture is they said, okay, I've got a transaction system like a Kix-based system. I know how to build services. Every Kix transaction, I'll wrap with Wisdom, and now I've got lots of services. All I need now is to connect all of these services together. And I'm doing service-based design, right? Well, there's a little problem there. And the problem is granularity. If each of these Kix transactions now becomes a service, and that service is wrapped by a service definition language, a web service definition language layer, then you've got to do a lot of marshalling and unmarshalling of lots of information, and the performance goes through the floor. So the first thing we learned is don't wrap every Kix transaction as a service. That's not the right granularity. The granularity of service is something larger. So we begin to learn lessons like that about how to create service-oriented systems, the right kind of layer, the right kind of granularity, some of the implications on performance and quality that are essential to service design. And we've documented those and we've built them into some of our tools. So how do you get started? How does an organization that's based on a 20, 30, 40-year heritage of building systems change the skills of its people to be able to build such systems? If you're in an organization and you try to introduce object-oriented technology, and they didn't understand that. So you try to introduce component-based technology, they didn't understand that. And now you're trying to introduce service technology. What makes you think they're going to understand that? That's the way lots of organizations are today. So as you try and deal with that, you have to introduce incremental improvements to how the skills can change, or how you can use existing skills to build new systems. So we have roadmaps that help people to say, how do I improve my organization? Where do I start? What kinds of skills? What kind of people are needed? What kinds of systems should I begin to change? And more than that, we can begin to say, how does an organization change over time? As you know, in our industry, maturity models are very popular. It's a way for consultants to make a lot of money. So maturity models are very useful because they give you a way of deciding where you are today, health check, where am I today, how good is my organization? If I'm level 1.3, does it mean I'll be better next year when I'm level 2? Maybe. So how can I mature over time, and where should I spend time? So there's a maturity model that's been introduced in the industry for service maturity. This is now being standardized by the Object Management Group. And it looks at different dimensions of your organization so that you can plot where you are today and produce a plan for where you'd like to be over the next 2-3 years. Where should I invest my time? Should I buy new infrastructure to improve my ability to connect systems? Should I do some work on the service architecture and design and do new design patterns? Should I look at my business process modeling technology and introduce new design, business process design techniques? All of those things? None of those things? So how do I plan that, and how do I understand that in relationship to my business? So that's what these maturity models do. So let's wrap up with a couple of critical success factors. So if there were 4 things that organizations need to make sure they do or don't do to be successful, these are the 4 that I would summarize. The first is, you have to view this, of course, from a human perspective. It's an enterprise change in your organization. So you have to focus on sustained change in your organizations. Many organizations I deal with, they're not committed to doing this over a long period of time. And when you reach that point, as we all do when we do something new, where you suddenly realize you're not as effective as you used to be doing this thing in a new way. Maybe you will be in the future, but you go through this little dip where you say, man, I don't know what I'm doing anymore. I used to know how to design a database with stored procedures, running and writing SQL for a SQL Server database. I know how to do that. Now I'm supposed to build an object-oriented system and a service-oriented solution, and I feel uncomfortable. I don't know what I'm doing anymore. You go through this dip that you have to come out of to be successful. You've got to work your way through it. It's not easy, right? There's a lot of human issues involved in doing it, which needs the support of the organization. The second one is about focusing on the life cycle of the services you're building. Making sure that you don't simply wrap every Kix transaction as a service, or focus on just building more and more services. You don't want to build services, you want to use services. So focus on their use. It may be better to focus in a small area, build a small catalog of services that are reused, than trying to focus in a large area to build a large catalog of services that nobody understands. So be successful and grow. The enterprise architecture perspective is about making sure that you make the link between business and IT more effective. And then finally, is looking at the infrastructure so that you can be successful and manage what you're building so that you can report back in a reasonable way against your business goals. That needs to have orchestration and optimization and report your key performance indicators is essential because management invests a lot of money in building new systems. Very rarely do we actually come back and tell them the money they're saving as a result of that investment and giving them some evidence about why that investment was necessary. It's important to be able to do that, to sustain funding, to improve what you're doing, and to optimize what you're doing. So these are key success factors that I'd like to end with. So these are the key areas. This is what's happening in industry as they look at trying to solve the problem of delivering successful systems. They're focusing on service-oriented architecture, enterprise architecture, and business process modeling and optimization. And there's a set of success factors and practical techniques that they're using to make that work. So I hope this has been useful. I know it's been a very quick overview, but I hope it's been helpful to you and given you a reasonable perspective on what we're seeing as we talk to industry about how to build successful enterprise solutions. We maybe have 30 seconds for questions. English or Turkish? Oh, good.
From Discord, I have a question. What do you think about open architecture in achieving successful service-oriented architecture?
So the question was, what do I think about open architectures in terms of successful enterprise solutions? So open architectures, it's an overloaded term. Open means several things. It means open in terms of using open source technologies. It also means open in terms of giving people access through open interfaces. And it also means using open design practices where the community has more involvement in those systems. Did you mean one or all three of those?
I mean them plus open standards, open interfaces,
Yep.
standard-based technologies.
So it's, in terms of open standards and open interfaces, this of course is key because this gives you the ability to use multiple suppliers of those technologies. It gives you a chance to make sure you benchmark yourself against others in your industry so that you're consistent, that you're using best practices, and that you're able to support that technology as it evolves over time. So all of those things are essential when you're trying to build enterprise systems and you're thinking about the long-term viability of those systems. So open architectures is a key point. Maybe if there were 4 areas I would have put on here, the 4th may have been that open area. In all of those senses I mentioned, not just open standards, but one of the things we're learning too is that we need to involve the community more in how we build systems. That's one of the things we've learned from Linux and Apache and all of those things is if we get the community involved, we get more ideas, we get more support, we get more innovation into the systems we build, and therefore we produce better products into the marketplace. So there's a lot we're learning in the commercial world about how to do that, and to do it effectively, and still to make money, right? That's what IBM needs to do. It makes $100 billion a year.
From Walsh University. About your experiences, you shared some about accessing the same information through multiple channels and then accessing heterogeneous information through a single channel.
Yep.
What I wonder is, do you see the third case, accessing heterogeneous information through multiple channels? Is it the combination of these two, or does it have a unique perspective?
Yeah, so the question was about accessing heterogeneous systems through multiple channels. And absolutely that is a combination of both of those ideas. Because as I mentioned, what we see is most organizations, including IBM, but also many organizations we deal with, have systems that have been built up over long periods of time, multiple technology sources, and often they're merged infrastructures. We're going through something right now. I'm involved in something where we're acquiring another provider of technology. And that technology was developed by different people in different geographies on different technology. And one of my responsibilities is, when this acquisition closes, what do we do with their technology? How do we make it all work together? And as we know, that's not an easy problem. So how you bring these systems together, how you access that information through different channels is one of the key challenges we find. And building that service layer, both in terms of the business service layer and its choreography, and treating your system as a catalog of delivered services from these underlying heterogeneous systems, is one of the key architectural approaches we're seeing in the marketplace to how to solve that problem. And we've got many examples where we're working with organizations to do that today. There's some interesting design ideas for how you do that. IBM's approach is a method that's called SOMA, Service-Oriented Modeling and Architecture, which tells you how do you build those service layers in a realistic way. And you can see documentation about that in developer works or in other places. Thank you.
You're talking about the static network environment, known services.
Just shout, it's okay.
Redesign services, redesign processes, so it's a kind of static environment. So assume that there is a new service which is not designed by yourself, so try to join the environment. It's an open environment, I mean, and such services may leave the environment. So, does your vision support such kind of openness?
Yeah, so the question is about dynamic services and service interactions and how new services are created dynamically. And of course, a lot of what we're doing is looking at that late binding layer for how do you create services dynamically on the fly. And a lot of what we're doing is based on policy, using runtime policy information that says, if I'm doing a credit check, and I have a credit check service, one way to describe that, so if I'm doing a credit check, and there's a credit check service, one way to describe that credit check service is not to implement it, but to describe the policy by which a credit check occurs. If it's 10 o'clock on a Saturday morning, and there's a certain loading on the system, and you're a gold customer that has another account with us, and you're doing a credit check, then maybe there's a certain way in which we solve that. That's different from if you're a new customer, it's a Monday morning, the system's heavily loaded. Maybe you do a completely different way of providing a credit check based on those contexts. So there may be a set of policy information that says, here's how we solve that problem. In one case, it may be a call to a certain database using an external credit check service. In another case, it may be something where we do something more rigorous, where we search our databases, where we go offline and somebody has to manually do something. There can be completely different ways of realizing services that may be context dependent and based on a set of policy information that gets implemented as a way of realizing services. That's one way we're looking at both dynamically creating new services and the dynamic implementation of services. And you'll see that, the start of that in some of our technologies today, but you'll also see more of that in the future. You'll see that in a number of industries. That's one dimension of the problem. The problem you mentioned is obviously a pretty extensive one. I think that was the last question, given I said I wouldn't keep you late in hand. So I hope it's been useful. I think I'll be here for a little while, so if you have questions, I'd be very happy to take them. Thank you.
I'd like to invite the symposium co-chair, Dr. Hüseyin Maksoy from Bilkent University, to express our thanks for Dr. Brown.
Yemek işimle mi oynuyorum?
Değerli katılımcılar, öğle yemeği Marmara Restoran'da yenilecektir. Saat 14'teki çağrılı konuşmacıların sunumlarına kadar ara veriyoruz. Herkese afiyet olsun.
Hocam biraz fişimiz var mı? Şimdi bir baksana, ben buradan kapatmaya çalışıyorum. Var mı şimdi? Abi nerede o? Nereye gitti? Ya yok böyle bir şey. İlkinde mi yaptı? Mutta mikrofon. Mikrofon diyor, niye mutta tutuyorsun diyor. Hayır abi, sonra muttan çıkarttım, konuşan yok, elimde fışıt fışıt, konuşan yok ama. Elimde mutta teleskop. Sonra dedim, niye mi çıktı? Öyle güzel. Düşüyor da orada. Bağırayım mı? Alabilir miyim?
Başarı geçmesini diler. Katılan tüm davetlilere selam ve sevgilerimi sunarım. Recep Tayyip Erdoğan, Başbakan. Yine aynı şekilde AKP Gaziantep Milletvekili Habib Mazıcıoğlu da sempozyum için başarı dilekleri iletmiştir. Bu oturumumuzda Borlat firmasından Wayne Littlefield tarafından yapılacak olan sunumu yapacağız. Wayne Littlefield'in geçmişi hakkında kısa bir bilgiyi İngilizce olarak sunacağım. Mr. Wayne Littlefield received his Bachelor of Science degree in Electrical Engineering from Rochester Institute of Technology in 1974. After working for over 20 years at Eastman Kodak and then at Rockwell Collins, he joined TerraQuest, now part of Borland, as Senior Principal Consultant in 1997. In the past 10 years, he has been a very active consultant on quality management, process improvement, and project management. conducting more than 80 CMMI appraisals, including level 5 as well. His domain knowledge spans defense, aerospace, finance, retail, insurance, manufacturing, and telco. Mr. Littlefield has been active in Turkey for the past few years, training and consulting the savunma sanayi specialty and several large Turkish software shops. Mr. Littlefield, I welcome you to Uyms.
I talk loud, so there shouldn't be a problem. Good afternoon. Thank you for inviting me to your symposium. We're here this afternoon for a very short amount of time, and I have a very important message to bring to all the participants that came today. The message is about a model. It's about a model that's been around for many, many years now, called CMMI. My introduction to CMMs occurred back in 1990 when I was working on a very highly visible project for Eastern Kodak. We were about almost 2 years late, about $2.5 million overrun, and there was no end in sight, and the project never succeeded. A friend of mine, who now works for Cisco, brought to me a model called CMM. Software CMM. I read that model and I bought into it as a project manager immediately. I thought it was the answer to our project. And we started promoting, if you will, process improvement within the company. So my friend and myself were the first adopters within that corporation to attempt to do process improvement using some CMM model. Well, it took us a long time. Why? Back in those days, as you understood from my introduction, I was pretty old. And back in the 60s and 70s and 80s, we didn't have internet. We just barely had client-server technology. So most of our process improvement initiatives were all focused on paper, writing massive tons of paper. Today, we are in a better position. Much better position to do process improvement. Do process improvement because we do have the tools, the technology. All we really need is an understanding of the model and how to use it. Going back, I have many friends in the audience. I know many of the faces here. Why? Because I'm working with many of your companies here in Turkey. I also work all over the world. I get to go home for 5 days next week, and then I'm off to Tokyo. Why? Because the companies in Tokyo are doing process improvement using CMMI. I also do work in Korea, Italy, the UK, Singapore. So it's not about where I travel to, it's about the model. And the model has become a world de facto standard as a collection of best practices for developing high-quality products on time, within budget. Now, many of you have heard of companies being maturity level 4, maturity level 5. Yes, no? A couple people have. All right. What's that about? What are these maturity level 4, level 5 companies about? Well, when they do process improvement, for the real reasons, it means that they're a high-quality company or division. It means that they can deliver on time, that their products are delivered with low defects. Notice I didn't say zero. I said low defects. They also can contain their budgets. These are companies that I've had the privilege to work with over the years. I've worked with Boeing Corporation on the 777 cockpit upgrade program. Worked with a gentleman there who was the quality manager by the name of John Booth. John wrote the quality management system for Boeing Corporation. I also worked in NORAD. For those that may not know, it's a system that's embedded inside of a mountain down in Cheyenne, Colorado. I've also worked on many other DoD and government contracts, mostly with prime contractors and subcontractors that were of higher maturity. or high maturity. Now I'm going to give you a couple of interesting stories. I've worked also with a lot of commercial companies, and I've been asked to come into a lot of commercial companies and a lot of DoD contractors. And I do work with CIOs, CEOs, senior executive managers, vice presidents, whatever you would like to call them. And many times, they want to get to CMMI level 3, or CMMI level 4, or CMMI level 5. And I walk in, and they close the door, and they ask me, what do I have to do to just get that certificate? I say, bye. Because process improvement is about keeping your companies in business, gaining market share, entering new technologies, happier customers. It's making the Turkish economy better through better IT, better products. That's why I'm here in Turkey, because I believe in the companies that I'm working with. I think I was already introduced to, in my introduction, I'm working with Aselsan, I'm working with Cybersoft, I've also worked with Siemens. I plan on working with as many Turkish companies as I can. Why? Because it's a worldwide standard, and it's a worldwide market for competition out there. Many of you probably work in technology, so you know technology is changing day by day. Right? Business conditions change day by day. Government regulations change day by day. Where can we gain a benefit of being able to be mobile, flexible, and agile in an environment like that? By having a solid process to do business by. So all of my life, or my consulting life, has been about process. It hasn't been about, doing a better technology or a better, having better people or a better education system. It's about a focus on process. How many of you know, and please raise your hand if you've heard this gentleman's name, Edward Deming. Okay, many people know who Edward Deming was. Back in the 40s and 50s, Edward Deming started working with a gentleman by the name of Cosby, and they developed statistical process control and and total quality management. I was very fortunate in my career because at that time at Eastman Kodak we were doing factory floor automation. I was doing high-speed electronic equipment control systems. Eastman Kodak brought Ed Deming in to teach many of our engineers, about statistical process control. He didn't teach the whole class, he just came in and gave a couple hours speech, and his students taught the class. That was way back in the 70s. Okay? But back then, there was a heavy focus in the manufacturing world on the quality of the process equates to the quality of the product that the process provides. Let me say that one more time. The quality of the process equates to the quality of the final product that's delivered or service. So if you can see what I'm saying, it's a pretty simple message. A high-quality process will give you a high-quality product. The problem is, what happens? Our projects become burdened. We don't have enough time to do process improvement. Why? Because we have to get the product out the door. So the problem with process improvement is getting executive management to understand that process improvement is an investment. It takes time, it takes people, it takes resource, it takes training, and most of all, it takes their understanding as to why are we doing it. Not to put a certificate on the wall, but to stay in business, have higher quality products, happier customers. So those are the companies I like to work with when I work with CEOs and CIOs and all those big high executives, the ones that really truly are doing process improvement for the betterment of their companies, for the betterment of their divisions, and for the betterment of their people. Kind of interesting, I've had all kinds of different experiences, as you might imagine, in my career. I've been very lucky for those experiences. Some of them were very, very enriching and enlightening and made me feel very good. Other ones made me not so happy. Because I have worked for corporations that spent millions millions of dollars on doing process improvement using this one little book. Millions of US dollars spent. And they never made any high maturity advances. Why? Because they didn't understand why they were doing process improvement. But getting to level 3 or level 4 or level 5 is a byproduct. It should be a byproduct of why you do process improvement. Okay? Now, those of you that may not know the model, I've been talking this level 4, level 5 stuff. The model is basically a set of practices that have been accepted worldwide. Practices in what? 4 major categories. Project management, process management, engineering, and support mechanisms for organizations and projects. So project management, for those that are project managers, if you know of the PMI certification, I forgot what it's called in Turkey, they have a separate governing body, but you can become certified to be a project manager. That means you understand how to build a realistic schedule, how to estimate the size of work product, how to do things like your earned value management, resource loading, calculating critical path. All those are accepted best practice activities that project managers do all over the world. Whether you're Chinese, Indian, Turkish, American, English, it doesn't matter. A good project manager knows how to run a project because they have the discipline and skills. What's usually lacking? The process that they're using. So CMMI promotes taking those very good project managers, putting them in an environment where they have a very formal process that will not allow a client, a manager, an CEO, executive, to impose a fixed date, unrealistic fixed date on a project. Has anybody ever heard of that happening? No, that's never happened. I have had it happen to me. When I was a project manager, it was very, very easy to have that pressure. Manager says something to the client, yeah, we can deliver that by October 28th. Then they come down on me and say, your project has to deliver on October 28th. I know for a fact my project is not going to deliver on October 28th. Well, what am I doing? Right? Yeah, okay, I can do that. This is how we've been doing business for years and years and years. That's why the model came to be, to eliminate those human behaviors. So a good process, number 2, a good process, not just the quality, but a good process, will assist us in being healthier human beings, in doing our business. Sounds kind of hokey, kind of crazy, but it's true. It's true. If you have a process that says there must be a renegotiation of an end date when there's a major requirement change or a major function change, then the process should allow the project manager to push back. Because the process said so, not because the person is taking it upon themselves. I hope you all see my point. Other thing I wanted to mention. I mentioned that when I was first introduced to CMM, it was back in Kodak. Then I moved to Rockwell Collins. And at that time, there was other CMMs that started hitting the market. There was a systems engineering CMM, SE. Then there was another model called CCAM. Then there was other models out there, People CMM. Dr. Bill Curtis, who I used to work with, People CMM. So all these CMMs started coming out of the woodwork. And in the late 1900s, in the late 1999, late 1900s, early 2000s, let me say it that way, there were many, many contracting companies in the U.S. that were very confused. Very confused. Why? Because they were pushing back on the U.S. government. And they were pushing back because, I forgot to mention, the United States government supports the CMMI by taxpayer money. The company of the Software Engineering Institute that supports this model. So the feedback was to the Software Engineering Institute at Carnegie Mellon University. What was the pushback? There's too many models. We have a systems engineering model. The systems engineers are arguing with the software people. And the hardware people, or the software people are arguing with our electrical engineers. And the people developing firmware are upset with the software developers. And there was no communications. Everybody was doing their own thing, and it was out of control. So, Department of Defense in the United States put together a group of people. A group of people. Where did they come from? Northrop Grumman, Lockheed Martin, McDonnell Douglas, Boeing Corporation, Texas Instruments, Raytheon. I could go on and on and on. My boss at Rockwell Collins was on the CMMI development team. I was very, very lucky throughout my career to be in the right place at the right time to learn the things that I've had the opportunity to learn. Why did I bring that up? Because CMMI was developed by a team of expert engineers, process improvement experts, managers, people that had performed process improvement. They have experienced success, and they experienced pain. So they put all these people together from these different companies, and engineers made this model. So it isn't a bunch of people that came out of a university thinking wonderful concepts and wonderful, ideas. These are tried and true practices that other companies over the years have used and found to be successful. Okay? So that's the model. That's what the model is about. And the model is made up of process areas. So I talked about project management. There's also engineering. So the enactment of eliciting requirements, developing requirements, keeping your requirements under control, developing good designs, having a good methodology, a good life cycle. Notice I'm not up here to tell you that XP and Agile is better than Waterfall. CMMI supports them all. CMMI supports everything because CMMI is product development. Product development. You could build a bridge with a bunch of contractors using CMMI. Why? Because it's good project management, it's getting good requirements, it's creating solid designs, reviewing those designs with the appropriate people, conducting the appropriate tests, putting the product together appropriately, and delivering. It sounds so simple. Right? It's so simple that the model, when you pick it up and start reading it, sometimes it's almost comical. Because you read it and you go, of course people should do this, of course projects should do this. But in reality, many companies, they don't. And I will be honest with you. Again, I think you heard when I was introduced, I did spend many, many years doing electrical designs, circuit designs, high-speed manufacturing control systems. Then I moved into ladder logic, programmable logic controllers. Then I moved into microprogramming, the 8080 chip. Okay? Assembly language, hexadecimal code. Then I moved into mid-range computing, factory floor operations, high-speed data collection. But it was on computers that many of you probably never heard of. PDP-11s, HP-1000. Then I moved into mainframe computing. I took training in COBOL, PO1. So guess what, folks? I'm not a process improvement consultant. I'm an engineer at heart. I'm an engineer. And I still have those tendencies to fall back into my old engineering ways. Why? Because when I was an engineer, I loved that power. I loved to be writing code. And nobody else knew what I was writing. All right? And back in those days, early software developers, we were mystical people to the other engineers. It was like, we have no idea what they're doing. They're banging on keyboards and they're looking at TSO terminals. And they just see command lines and they don't know what's going on. So we were really, yeah, whatever you guys say. So what happened? We became undisciplined. We became undisciplined. My son is taking computer science in the US right now at a university. Unfortunately, process improvement and CMMI is not being taught in American universities. It's one of these things that the SCI has been promoting for many, many years, but I will share with you. My very own son, who's 22 years old, is just like I used to be. Only he's writing Java and, you know, HTML and all these other languages. Okay? So, with all that said, let me talk about process improvement real quickly. What is process improvement? Process improvement is a program. It's a project. It should be handled like a project. It should be run like a project. Okay? What do I mean by that? Projects in companies typically make money. When you execute a project, you have a client, somebody that's paying for that effort. Who's the client for process improvement? The employees. So in a company, the hard part about doing process improvement is for, again, executive management understanding that they need to conduct a formal project within their company for the benefit of their customers, their employees. And the byproduct, the wonderful thing that comes out of it, is the process. The process. What I mean by that, and I talk to a lot of executive managers, and it's funny because they don't seem to understand sometimes that a process to a company is just like this laptop up here is. Do your companies invest in your tools, your computers, your networks, your servers, you know, everything that you use, your configuration management tool, anything that you use is an investment by your company. Why? To help you do your jobs better. Why can't a process be an asset and be looked at that way? That this is an investment in the company to do business a better way. And it's not just about product development. My tentacles reach much further than just CMMI. For the last couple of years, I've actually worked with other companies in other process improvement initiatives called BPR, Business Process Reengineering. Fixing accounting systems, not systems, fixing the process. Fixing material resource handling processes. Not just the system that governs an MRP system, but the people that use the process underneath that system. I'm leading up to something here that I hope you understand when I finally make my point. If it's perceived that processes are a valuable asset, executive management understands that by implementing high-quality processes, improving our high-quality processes, and constantly becoming better and better and better, we'll win in the end. Now, why doesn't it just happen like that? It's kind of funny. I will share with you a real-life thought that I had in my head back in 1988 or 1998-99. I wanted to try consulting. I left Rockwell Collins and I went and moved into the consulting field. I thought I had maybe a 5-year stretch. Because I had this perception in my mind that the world at that time in history was grasping CMMI. Everybody was gobbling it up. It was a good thing. And I saw myself over the years, once it's accepted, everybody's going to just adopt it. Well, it's still one of these things where there's still companies out there that start their program and then it goes down and then they start it again and it goes down. Why? Because of all of those external factors I was talking about earlier. Changes in the business climate, changes in organizational structure, changes in acquisitions and company divisions and splitting up and all coming together. It just goes on and on and on. These are all really big enemies to process improvement. So my point, what do I do when I consult with companies? And many of the people in the audience that I talked to and had the privilege of working with have heard me say this way too many times probably. Process improvement. Usually I have the 80-20 rule and it's worked in every single situation I have ever been in. What I mean by that, 20% of a process improvement initiative is about writing and deploying the process. I can go into any one of your companies, and if you want me to write you a project management process, I can probably do it. It's not that I'm bragging, it's just I've seen a lot of implementations of project management processes. All I need to know is how you do business, and we'll work with you. No problem. But what typically happens is these programs start up. There's a flurry of activity. Everybody's writing process and writing maybe HTML and forms and templates and all kinds of wonderful things. And then they throw it out there for the projects to use. The projects go, I'm not doing that. What are you, crazy? We never had to do that before. Why do I have to do it now? 80% of process improvement. I kid you not, I've never experienced any other formula. Organizational change. Organizational change. An organization cannot adopt process improvement without stepping up to the plate and getting everybody in that organization on board that we're going to change. We're going to do business better. We're a team. I know it sounds like rah, rah, rah, but that's what process improvement is. And in the companies where I've worked, where they have had great successes, it's because executive management, all the way down the chain, to the engineers on the floor, were all on board. Because it's not easy. It's not easy. As a human being. Okay, the rare times that I'm home, I get to drive. Right? And it just drives me crazy. I have the same route that I use every day going from my home to the store. Every day. If I'm driving down the street and all of a sudden the road is closed, it makes me mad. Now I got to go another way. I have to change. I have to do it different. So what's organization to change from? Behavior. Human beings. People. And probably the one biggest, I can't even put a word on it, an English word. The biggest experience, the greatest experience that I have had the most fortunate opportunity to experience personally is to work all over the world. Because I work with Koreans, Japanese, Indians, Chinese, French, Italians, and guess what, folks? We're all human. We're all human. Their project managers are just like your project managers. Their engineers are like your engineers. And their managers are like your managers. So there's this common denominator of the human element. So when I do consulting, I try to get across that I can teach you the model. But I can't teach you how to change your organization's human behavior. I can give you examples, but I can't give you a slideshow presentation on how do you change people's attitudes. So most process improvement initiatives are about having an organizational change strategy. Okay? Now, I want to, before I wrap up here, because I have 15 minutes left? Okay. There's another important topic that I haven't shared with you about process improvement, and then I want to open it up for questions. That is, I've been talking about process. Process, process, process. But process cannot survive without having good people and good technology. Okay? So that's the other message here, is that there's a triangle. There's a triangle. It's people, process, and technology. So yeah, having a good process is great. But having good trained people and having a technology that will support that process is paramount. It's necessary. It's like a three-legged stool. You need all three. The model, CMMI model, talks about process. Okay? It doesn't give you direction on what technology to use. You know, what educational level your people should have. That's up to you. That's up to you. Why? Because the model fits into every context that you can imagine. I work with some organizations where there's thousands of people in the organization. also work for a company in Denver, Colorado. There are 27 people, and they're maturity level 3, which means they have a standard process. Their CEO codes. They do web-based applications. But their CEO understands that when he puts his coder hat on, he's executing the engineering process. When he takes it off, he puts his CEO hat on. But there's a focus on process. So I wanted to make sure I brought up that point, that this, just having a good process is not the answer to everybody's problems. It takes a delicate balance of all three. I guess I'm pretty close to wrapping up. I did want to mention a couple other real quick topics that just to extend here what this process improvement thing is about. Elaborate a little bit on what I was talking about, maturity level 4 and 5. The model, when implemented, the way the CMMI team expected it to be implemented, takes an organization on a journey. It's a journey. It's like taking a trip. If you plan well for your trip, you will be successful. You'll be gold at the end of the rainbow when you arrive. What's the trip? These 5 maturity levels I've been talking about. And I forgot to share that with those of you that may not know the model. The model ranks organizations. I think when I was introduced to you as a lead appraiser. I'm a lead appraiser, which means I've been certified by the SCI to go into an organization and appraise their maturity level. How mature? How grown up are they? How grown up? How much experience do they have under the belt of life in that company using their processes? So level 1, processes are ad hoc. There's a high dependency on the heroes. I told you, I'm an engineer at heart. I used to be in a level 1 company and I loved it. Why? Because I got rewarded. When I had called in the middle of the night to fix my broken code, fix my broken applications. Level 2. Level 2 is basic project management and a number of support mechanisms. Having your work products under control, under some type of configuration management. Basic project management is being able to plan a project appropriately with realistic plans, not just a document that says this is what we thought we would do, and then go off and do just the opposite. Right? That's level 2. Heavy focus on individual projects being able to repeat their successes. Level 3. We grow up. We start organizing our processes at the organizational level. So now, projects that live within one organization are sharing. They're sharing best practices, lessons learned, quality data. If any of you ever talk to people from these high maturity companies, they should be able to tell you things like the defect densities of their products. I'll talk a little more about that in a second when I get to the next level. But at level 3, it focuses on a standard process that would be used across your greater organization. Why? Better communications, more sharing, and more success. Level 4. Once we have that standard process, we now have a maturity level that allows us to start understanding what those processes are capable of quantitatively. That means we're doing things like statistical analysis on our processes. We start using things like control charts, run charts, U charts, XMR charts, Pareto analysis. Okay? And we actually start managing a project using statistical techniques. Level 5, utopia. Continuous process improvement, okay? It means that a level 5 company is just, the whole organization is engaged in process improvement. There's no more organizational change required. Everybody understands and participates in continuous process improvement. Part of their job every day is to be thinking about how can I improve this process. It sounds kind of crazy, but I've actually seen it. One opportunity that I had that I'm very proud of is a company that I worked with in Korea, Seoul. They're called Pose Data. They developed some of their own technology and stuff, but what I was impressed about them is that I met their CEO. And they were a company that was born as a spin-off from POSCO. POSCO is the biggest steelmaking company in Korea. They took a part of their IT organization and they made a company out of it. It becomes SI, System Integrator. The CEO that they put in there, he holds records for being the most nominated CEO, renominated CEO in Korean computing type businesses. He was 69 years old when I met him. He's now retired. But the interesting thing is, and I learned from him, he thought he was going to learn from me. I learned from him because he was giving me the philosophy of how he runs his company. And he said, it's very simple. It's my personal philosophy of my life. He said, I am a lifelong learner. I continue to learn until the day I decease. There's always something to learn. And he promotes that throughout his company. He expects everybody in his company to adopt this lifelong learning attitude. And then he aggregated it out and said, our company is a lifelong learning company. Pose Data paired with Intel, and they made the first supercomputer in Korea that they're using to do cancer research. They're now into product development. They make a DVR. They just had a mega contract that was signed with the United States to put these cameras all over the United States airports to do constant surveillance and recording. This is a company that is growing. I don't even know what their growth rate is. It's phenomenal. But when I looked at their processes and appraised them, it was unbelievable because most of their, how would I say it? Most of their processes were so highly automated that we had to appraise their technology rather than their processes. But everybody knew and everybody participated. And when I talked to engineers, they understood what statistical process control was. And when I talked to their testers and their configuration managers and their quality assurance people, this is a company that's growing very, very quickly. So that was one example that I wanted to share with you that it truly, truly does work. And it will help a company. I think that's about all I was going to say today. I would like to make sure we have about 10 minutes or so to open it up for questions in case anybody has any. And I am okay to answer any type of question you would like. Process improvement, other companies, how long it takes to get to level 3. I'm always asked about that one. Do I know any CEO superstars? Have I ever met Bill Gates? No, and if I do, I have some words for him. Questions? Oh, there has to be one.
Okay. Just to heat it up, I have one question.
Yes.
When we are considering about quality and process improvement, we are always talking about a singled out organization. What about doing things collaboratively, not like outsourcing, but doing things real collaboratively, which is a rising trend in IT? How would CMMI framework assist companies to improve their performance in collaborative work?
Can I ask one question about what you mean by collaborative? It's like a shared project?
Yes, exactly.
Okay. It supports it in a number of different contexts. So I have to sort of reverse engineer your question into what contexts would it address. Typically in our business, especially government contracts, DoD type contracts, you have a prime contractor that's using subcontractors. The model will assist there with helping with process areas such as supplier agreement management, doing appropriate negotiation and agreements up front. That's one. There is another aspect of the model that I'll stick my neck out here. There's a piece of the model that was developed by the United States Air Force called Integrated Process and Product Development. It was used in the U.S. on the V-2, the F-22, and for very, very sophisticated projects where the final tangible product was only a concept. It really wasn't a tangible thing that had ever been made before. So this IPPD is a teaming environment that has a set of process areas that allows you to use teams from multiple companies without having to be primarily focused on the contractor-subcontractor relationship. It is a very, very formal, but it has to be implemented with due diligence. You have to be very careful about having all the companies sign up in advance that they will buy into the entire concept of using teams of people from their companies. So there's a lot of upfront negotiations about money and all that. The model doesn't talk about how to negotiate money and contracts, but it does support the infrastructure. We're setting that stuff. Did they answer?
Yes, exactly.
Any others? Any from the people I know? Yes, sir.
So, okay, yeah.
Yes.
My name is Serkan.
Nice to meet you.
As we know, there are one more methodologies for software engineering. Microsoft Solutions Framework, where is it in the line of methodology?
I worked with Wachovia Bank in the United States. We're doing MSF, Microsoft Software Framework. It fits, it is, I don't want to say it's 100% compliant, but it's Microsoft's answer to RUP or any other methodology that's out there. Okay? It's the best way I can say it. I do not know of anybody that has personally sat down and mapped Microsoft's solution framework to CMMI, but because there's too many other methodologies out there that already have been, that companies are more readily adopting. So I'm not putting MSF down. It's not that bad of a process. It's a good process, but I can't stand up here and tell you if you adopt MSF, you will be level 3. Yes. And by the way, Microsoft is not doing CMMI processing. I'm not bad mouthing them. They just chose. They don't need to. Most richest company in the world. I mean, they don't have to do. We test their products for them. This is not tape, no less, right? I'm in trouble. Any others?
Okay. So I'd like to invite Mr. Ramazan Tektaş, Chair of the Ankara branch, for expressing our thanks to the development.
Before we officially end, I would very much personally like to thank each and every